can, instead of just looking at the number of thalia, we can go on and do growth rate. Now, growth rate is something that we taught you in OneNote. I have a look here. Under our basic duckweed experiment, we showed you guys how to calculate growth rate. Now, with the way that we collected the data, the best one to focus on is this, just the rate. That's calculating R. And the way we calculate growth rate of each of the different trials is the change in the number of the thalia divided by the initial or starting number times by the amount of time that's elapsed while it was growing. Very simple equation that gives an awful lot of information here. So how do we apply this to here? Basically, the first thing you do is you set up a simple table like this, and what I've got on the side here is first my initial number, which is one of the first things I need to know about my thalia. To find the change in the number of thalia, you'll need to know the final count, so this is the initial, this is the final one. So in this case I've picked day 10, but you could do this between day 0 and day 3 and day 3 and day 5, it's up to you, but I've just done first day, last day, and between those two I can then work out the change in the number of thalia. And then change of time. So if I've done it from 0 days to 10 days, my change in time is 10. And then we can get it to work out the growth rate over here. So first thing you've got to do is just go and copy and paste some numbers in. So first we need our starting numbers. So if we go back to our original numbers here, our starting numbers, basically we just copy and paste all of this in. Now you can put in your mean and your standard area there, but we won't be using it at this point in time. Just paste in the values only, and there you go. So that there is, I'm not sure if I'll use mean and standard area in this video, but never hurts to have it there anyway. And here we've got them in there, so the next thing we're going to do is work out the change. Now we don't have the change for some of these because we ended up not having them counted, so essentially we have to wipe out these trials. I will wipe them out in a second. Let's just put in change. So the change in my number, so it's what I ended up with minus what I started from. Started with 64, I ended up with 115 in that trial. That means in total I had 51 increase in number of thalia. Now once you've typed that in, if everything is set in the columns like that, all you have to do then is go copy across and it will do that. See this? If I double click, it'll show you it's using that one minus that one in this formula and that one minus that in this formula. Then you just copy it down. Okay, very, very easy. So once you've done that, these ones here that are negative because we actually didn't do a final day count, they're going to need to be removed because they're actually not valid data at all, and we end up with 4 trials. Okay, so I now have my initial number, my change in my number. What was my change in time? Well, it was over 10 days. So every single one of these is going to be 10 days. Now you might wonder why I've put it down 3 times. Well, it's simply so I can copy across formula. If you put it through once, you have to type in the formula 3 times. Type it in 3 times, you only have to do the formula once. So growth rate, I'm going to show you how I did this. So I'm going to delete these. Growth rate. My growth rate is my change in my number divided by my original number times the change in time. So equals my change in number, that's this one here, divided by, that's the slash, my original number, 64, times is shift 8, and then the amount of time that we grew them for, 10. Enter. There it is. And once you've done that, you just have to copy across and down to work out your growth rates. and then delete any of these ones that are 0 because we didn't have data in those columns. And there you've got the growth rates of each one of those beakers on each one of those days. The last thing that I would suggest you do is you can actually get it to analyze these statistics. So again, put in the mean of the growth rates and stuff here. We can, so the mean and the standard error is there. You can just copy it and paste it in. Once you've got that growth rate, you can now put that into a graph. So there's several different ways you can present this data in a graph. One is more complex than the other. The easiest way is just to graph your average and compare it as a bar graph and then put in your standard error. I'm going to show that first. The other way would be to actually make what we call a scattergram of this data, so that we can actually do some further data analysis on it to see how reliable the pattern is that we have here. So let's do the first one, growth rate, just the averages. So I say I just want to graph the growth rates. Insert a graph, bar graph in this case, and it pops it up. Now that data means nothing yet unless I actually put some titles and stuff in here. So first thing I need to do is to tell it to add some elements here. I'm going to add in a title for the axes. The axis title here is my different, so this is what are each of these groups. Each of these groups are the different concentrations of medium. Okay. Then I need to tell it how to label these groups here. Now, essentially that was 0%, 33%, and 100%. Okay. So if we add that in, we just tell it here. Actually, no, you can do it up here if you want. You go select data and you say, okay, I've got this data here, but I need to know how to label the different categories in it on the horizontal axis. You have to show it where those names are by doing that. And when you do that, all of a sudden they pop up there. Chart title would be, you have to tell me what I'm comparing. Growth rates in different concentrations of medium. You also have to make this number mean something here. Okay, 1 to 100, that really doesn't tell me anything until you tell me what it's about. So that's my Y axis there, my vertical axis. I need to give it a title that relates to the growth rate. And if it has a symbol assigned to it, you've typed that in as well. Here too, that concentration of medium, its units are in percent. Which means I really should take that out of there and just put 0, 33, oops. I want these only as numbers because in my next video that's really important. So I'm just going to change these back to numbers with no zeros. So I've got 0%, 33%, and 100%. Okay, and I have a graph. Now the next thing I have to do is we've got to calculate standard error. Now I've usually said don't worry about this. However, in this case, standard error does help us at least judge the amount of error between the different groups. Okay, so what we're actually going to be doing here is showing you how to plot that, and because you haven't had to put in a fancy formula, it's really, really easy. we need it to put in some error bars. So we're going to go back into chart design and go add another element. I want error bars. Not just any of these ones here, I want to go more error bars. Now it will just do the same error bars for each one of these and just do an average if you don't do this. But you might notice up here the amount of error is actually quite different between the two groups, 3, 22 and 11. There's a huge amount of different standard error there. So we have to get it to reflect that in these error bars. You go custom, specify value. And you basically have to get to show this error above and below that line there. So you highlight your standard error like this, and it pops those numbers into each one of those 3 columns because it notices there's 3 columns there, 3 columns here. It will then pop them in and adjust it, and there they are. A little bit further now, we use these error bars to just introduce whether or not we think there's what we call a statistical significance between the different groups. So technically, if you had different conditions for each group that they grew in, they should actually have different data if that condition affected them. So if they had different amounts of medium to grow in, different amounts of nutrients, theoretically, if nutrients affects growth rate, there should be a significant difference between the growth rates in each of those different groups. Okay, you should see a significant difference in numbers and growth rate in the distilled water group compared to the 33% nutrient group compared to the 100% nutrient group. There should be differences that are easy to see. Now this is how we tell. Now this is just the very basics of statistical analysis here using these standard error bars. See these little guys here? We're looking for a statistical difference between them. So we look at, say, this bottom one here, and I should have got my ruler one out here, but I'll just draw it here. You can see that with his error bars, there is absolutely no overlap between his error bar and the other 2 groups. That means that there is a statistical significance between these 2. Okay? In fact, we would say that there is a statistically significant difference between the growth rates of the duckweed in the distilled water compared to the other groups, because there's absolutely no overlap of these bars here, okay, that we can see. So that is a point in the fact that the error here is quite low and it is statistically significant. The distilled water has had an effect on growth rate compared to some nutrient medium in these other groups. However, look at what's happened with the other groups. So there is definitely some error there, and there is a no statistical significance between group 2 and group 3. In other words, we can't prove that going from 33% medium up to 100% medium actually changed the growth rate at all, because look at how much overlap we have in the error bars and in the data. So that means that if we had to type that up and put that in, we could say that there's no significant difference between the growth rates of the 33% medium and the 100% medium because of the overlap of their error bars there. So that's a basic statistical error analysis. And it points to the fact, I'd say, that there is a huge amount of error, I'd say, in group 2, because look at the amount of standard error compared to this one here. If you actually go and look at the values, there they are. It's double the amount of error of group 3 and 7 times the amount of error of group 1. So there's a huge amount of error, standard error, relatively, in group 2 that needs to be addressed and talked about. And that'll be why we can't see a statistically significant difference between the 2. So when you put in those bars like that, look for overlaps. That's a very basic and easy way to talk about whether or not you have error in your data. So at least try that for presenting your data and talking about it. And if you'd like to then go and do a more in-depth analysis using regression analysis, then that's one of the following videos.